Okay, dear friends, we are now going to see the Kurskal'S minimal spanning tree algorithm. In fact, that is what we saw in the previous video, how we have seen what is a minimal spanning tree, and it finds for a given graph the minimal spanning tree. That means minimum edges such that it connects all the vertices. So here is the algorithm. So let's imagine the tree that we had seen before, the graph that we have seen before. So this is a graph. So for that graph, we are going to see how we can build the minimum spanning tree. So Yes. So what we do, this is algorithm, the step, we'll just explain. First we construct a forest, meaning only the nodes without the edges. So the nodes are here. Then we arrange the, the edges in ascending order, okay, as from the diagram. So this is the smallest, this is the biggest. So of course, each will have it we can think this as having a vertex here, a vertex here. I have only written the weight of each edge. Then we take the smallest and connect. So here the smallest is 1, that is between C, or these two are the smallest. So let's take this A and B. So we can take this and we can connect A and B. We take that. That means the first one is taken 1. Then we have one more one. So we take, I think I've made a little mistake here. So we take this, that is C and E. This is connected, another one, C and E. Then we have many twos out of this. In the graph, we pick up, let us take the original graph. There are many twos. So I take this two and between D and C. Now any more connections? So there was a one more one. This should be one actually. One more one, and so this is gone, and this also is gone. For we don't connect, by connect it will create a loop, or this will create a loop. So we get, so this is a minimum spanning tree. Of course we can get it different ways, depends which twos we connect. Suppose we connect this, also suppose we have 2, we can have another ignoring this. So there are different ways you can get a minimum spanning tree, but the length is such that it is minimum. So that is the minimum spanning tree. So here is the algorithm often asked with an example. Explain what is minimal spanning tree, draw a tree, construct this minimal spanning tree, and this. So whenever, if it forms a loop, for example, if I take the value 4, that is between A and D, it will form a loop. So I will ignore that. So that is the algorithm. So that is how the nodes, the minimum spanning tree gets connected. Now, having seen the algorithm, how do we implement this in a program? So that's important. Now to implement, we use a parent logic. That means for every node, I should know who is its parent. And the moment I get connected two nodes, a parent gets a child. That means its rank increases. So we use two arrays. One array is called the parent array, consisting of as many as size of number of vertices. So A, B, C, D, E. You can use a 0, 1 for processing as integers is here. So here I initialize every node, its parent is itself. That means A's parent is A itself, B itself, C is itself. Because initially they are this way. I'm just taking 3 examples, 3 nodes. So C, D is E itself. So that is initially the parent. Then I have a rank array wherein for each node it is initialized as 0, meaning this has no children, or this has no children. So a node does not have any children initially, there is only forest, so they are 0. So the moment I get 2 connected, its parent changes, rank 2 changes. Now let us see, I am going to connect these 2. So I can connect if they are not belonging to the same family, meaning imagine it as a marriage. Okay, simple example. Suppose D is C's child, E is also C's child. I cannot connect these two because they are siblings. So a marriage is not possible, meaning I cannot connect these two because it is forming a loop. It is similarly, if I have got child of E is, so let's say F, F is child of E and C is his parent, I cannot also connect this to F because it will again form the loop. So that is an important logic that we need to follow. So I should know for each node who is a parent. So I use this algorithm find, go through this. The find is used to find who is its parent. So the moment I get I, okay, I'm going to find out who is the parent of, let's say I want to connect C and E. So they can be connected if the parent is not the same. That is how the algorithm works. So C's parent, who is C's parent? C's parent is C. Who is E's parent? First, E's parent is E itself. So both are different. So I can connect C and D. So I connect these two. So let's imagine this way. C becomes a parent of E. That means now E's parent is C. His parent is C. His parent has become C. Okay. So now, and C has one child, so which means C's rank will become increased by 1. That is how the rank algorithm function works. Okay. So rank is, it has increased, so the rank has changed. So now I'm going to connect, let's say I'm going to connect E and D. Okay, so I need to check who is D's parent, who is E's parent. So who is D's parent? D's parent is D itself. But who is E's parent? E's parent is C. Okay, so I'm going to check E's parent is C, C's parent is C, that means the grandparent is C. And who is D's parent? D's parent is D itself. So E's parent is C, okay, and D's parent is D. Both are different, which means I can connect this two. I can connect this two, or I can connect this way. C's parent is C, D. Depends how you want to, which are the two nodes you are going to connect. So let's imagine I'm going to connect it this way. Okay. All right. Which means E becomes a parent of D. E becomes a parent of D. E becomes the parent of D. Okay. So D's parent is no more D. Now it is E. So this is changed, and E's rank increases because E has become the parent. E's parent is D, and D rank, sorry, E's rank goes up because he got a child. Let's just imagine that way. So goes up. Okay. Now we know by rule this cannot be linked because this is, it will form a loop, or the parents are the same, meaning D's parent is actually E. So look at D, D's parent is E, E's parent is C, correct? So we come here, and C's parent is C. So both are same. That means D's parent is C and C's parent is C itself. So because of that, this linking cannot take place. So it will not be linked. So that is how. So these two algorithms are explained here, how find and union rank, that is changing the rank increases. Now look at the algorithm. The algorithm is this. Okay. So what we do here, what we have are the edges. I hope it is clear. So we have, using a linked list, we create each edge, okay, u, v, and its weight, okay, our structures, linked list. Then we are going to call edges one by one. And when can the edges be linked? When the parents of one, u, okay, and v are not same, they can be linked, or those edges can be added into the linked list. So it will add only those edges that will not form a loop. I hope it's clear. Thank you so much. Please go through this, take the graph, go through the algorithm, and with pen and paper do the work. I think it should become clear to you.